Hi, good morning, friends. In the previous class, we learned how to find the inverse of a matrix using cofactors. Today, in this session, we shall discuss the applications of determinants and matrices for solving a system of linear equations in two or three variables. Here, first we'll see solution for a system of linear equations using the inverse of a matrix. So let's consider the system of linear equations that is like that. A1x plus b1y plus c1z is equals to d1. A2x plus b2y plus c2z is equals to d2. Again, a3x plus b3y plus c3z is equals to d3. Here, x, y and z are called as what? Variables. So we have to find the values of variables. That is solvation of system of linear equations. Okay. Here it means we have to find the values of x, y, z. These are called as what? Variables. Here let the simultaneous equations be a1x plus b1y plus a1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3 be the system of linear equations. So now this can be written as that is a is equals to write the coefficients of x, y, z. So that is a1, b1, c1. Similarly, write the coefficient of second equation, that is a2, b2, c2. Similarly, write the coefficient of third equation, that is a3, b3, c3. C3. Usually, this matrix is known as coefficient matrix. So writing the coefficients of x, y, z. So while writing the coefficients of x, y, z, see that the variables x, y, z must be in an order. Okay. We know that, for example, next here, what is the coefficient of x? 2 is the coefficient of x. For example, x minus 2y plus 4z. Here, what is the coefficient of x? It is 2. What is the coefficient of y? It is minus 2, not 2. Okay. Coefficient of y minus 2. Okay. So that is what is the coefficient of z? That is 4. Okay. Remember this. So now writing the coefficients of system of linear equations will get a coefficient matrix. Then x is equals to, that is variable matrix. What are the variables? X, y, z. That is x, y, z. Okay. So remember, they are the variables. Usually these x, y are elements. This is called as matrix itself. Next, that is again b is equal to, okay, write the constants, that is d1, d2, d3. Usually this is known as constant matrix, and this is known as variable matrix, which we need to find. We have to find the values of x, y, z. Okay. Again, remember. So these are the system of linear equations. Then write the coefficient matrix. So before writing the coefficient matrix, see that the variables must be in a particular order, that is x, y, z form, and bring the constant to RHS. Always see that the constants must be in right hand side, right at the side. Now write the coefficient matrix, variable matrix, that is x, y, z. And the constant matrix, write the constant, that is D1, D2, D3. Okay. So now this can be written as what? That is A x is equals to B, right? If you multiply a coefficient matrix with variable matrix and equate to matrix, constant matrix, you get same simultaneous equations. Now this can be written as what? Ax is equal to B. X is equals to B. So if A is a non-singular matrix, if A is a non-singular matrix, we know what is non-singular matrix? Whose determinant is not equal to 0. Determinant of if A. Determinant of A is not equal to 0, then we call such a matrix as what? Non-singular matrix. We know that only for non-singular matrix, the inverse of a matrix exists. So remember this. Again, if A is a non-singular matrix, if A is a non-singular matrix, then how? That is it. Ax is equal to B. So free multiply by A inverse. So free multiply by A inverse. Therefore, that is A inverse. A inverse into A into X is equals to A inverse into B. Free multiply by what? A inverse. Therefore, A inverse into A into X is equal to A inverse into B. So we know that what is A inverse into A? Any matrix multiplied by its inverse gives an identity matrix. Therefore, I into X is equals to A inverse into B. A inverse into B. So we know that any matrix multiplied by an identity matrix gives an matrix itself. That is X is equals to A inverse into B. X is equals to A inverse into B. So this is a formula to find the variables. Okay, that is what is X? X is equals to, we know that X, Y, Z. Inverse of a matrix. Inverse of a matrix. Then we find what? Inverse of which matrix? That is coefficient matrix. So this is B. B is which matrix? It is a constant matrix. Multiply the inverse of a coefficient matrix by what? B. Then we get the values of X, Y, Z. Again, remember. So write the coefficients of system of linear equations in the order, that is X, Y, Z form, right? For coefficients of first equation, coefficients of second equation, coefficients of third equation. Usually this matrix is known as, then write the variable matrix, that is X, Y, Z, X, Y, Z. Okay. So then this is known as what? A variable matrix. Then write the constant. See that you, before writing the constant matrix, bring the constants to RHS. Right? B is equal to D1, D2, D3, D1, D2, D3. That is constant matrix. So then, so these equations can be written as what? Ax is equal to B. So if you multiply A with variable matrix, that is coefficient matrix with variable matrix equal to matrix B, then we get the same simultaneous equations. Therefore, if A is again, if A is a non-singular matrix, then we have it is free multiplied by what? A inverse into A into X is equal to A inverse into B. We know that subgrouping these two terms, any matrix multiplied by its inverse gives the identity matrix. Therefore, Ix is equals to A inverse into B. So we know that any matrix multiplied by identity matrix gives the matrix itself. Therefore, X is equals to A inverse into B. You should remember this formula. Okay. So to find the values of X, Y, Z, X, Y, Z. Okay. So we will see some problems based on this. So we have solved the system of linear equations by matrix method. The equations are 3x minus 2y plus 3z is equal to 8, 2x plus y minus z is equals to 1, 4x minus 3y plus 2z is equal to 4. These are what? System of linear equations. Linear equations. We know that we have to find right what coefficient matrix, variable matrix, and constant matrix. Usually, finding the solution of such equations by writing the coefficient matrix, variable matrix, and the constant matrix is known as matrix method. Matrix method. Okay. So by using matrix method, we have to solve this simultaneous equations. So now write the coefficient matrix. So that is A is equals to coefficient matrix. Right, see that the first the equations are in a order. Of course, they're in an order, and the constants are towards the right side. Okay. So now coefficient of x, that is 3. Here, what is the coefficient of y? Minus 2. Coefficient of z 3. Again, coefficient of x 2. Coefficient of y 1. Coefficient of z minus 1. Coefficient of x 4. Coefficient of y minus 3y. Coefficient of z 2. Okay. Now, what is the variable matrix? That is x is equals to variable matrix. X, y, z. Then we write constant matrix. That is b is equals to constant matrix. Write the constants. So that is 8, 1, 4. Right. So we have the formula now. That is x is equals to a inverse into b. A inverse into b. Here we need to find a inverse. Right. So what is the inverse? We know that a inverse is equals to 1 divided by determinant of a into adjoint a. Here we need to find the adjoint a matrix. How to find adjoint matrix? For that we need to find the cofactors of each element. Okay, now let's find the cofactors of each element. Okay, so now we'll find the cofactor of that is a11. This cofactor of a11 is equals to already we know already that how to find a cofactors. So had that is substitute 1 plus 1. So that is 2. 2 is an even number. That's right. Plus determinant of. So you ಯಾವ element ಅನ್ನ cofactor ನ find out ಮಾಡಬೇಕು. ಆ element ನ row ನ column ನ ಬಿಟ್ಟು remaining elements ಅನ್ನ determinant form ಅಲ್ಲಿ ಬರ್ಕೋಬೇಕು. So cofactor of 3 ಅಂದ್ರೆ ಈ row ಬಿಡಬೇಕು, ಈ column ಬಿಡಬೇಕು. What are the remaining elements? 1 minus 1 minus 3 gain 2. Again that is equals to plus. Write the plus as it is. Okay. 2 into 1, 2 minus into minus plus. That is 3 into 1. That is 3. Again that is equals to 2 minus 3 minus 1 minus of plus because what minus 1 itself. Again cofactor of a12 is equals to 1 plus 2 3. 3 is an odd number minus. So again that is determinant of cofactor of e minus 2 are leaving this row under. Sorry, leaving this column under row. What are the many elements? That is 2 minus 1 4 2. 2 minus 1 4 2. Again that is equals to write the minus as it is. Minus of we have 2 into 2 that is 4 minus. So 4 into minus 1 minus 4 minus of minus plus we have plus 4. So 4 plus 4 8. 8 into minus 1 that is minus 1 that is minus 8. Again so we have cofactors of a13 that is equals to 1 plus 3 4. 4 is an even number, right? Plus into determinant of. So cofactor of this element leaving this column under row. What are the many elements? That is 2 1 4 minus 3 minus 3. Again we have that is equals to and the plus as is plus of 2 into minus 3 minus 6 minus 4 into 1 that is 4. Okay, again so we have minus 6 minus 4 minus 10 minus 10 into plus that is equals to minus 10. Next cofactor of next element that is a2 1. So a2 1 is equals to 2 plus 1 3. 3 is an odd number, right? Minus determinant of cofactor of 2 and they are leaving this row and the column remaining minus 2 3 minus 3 2. Okay, that is minus 2 3 again minus 3 2 again that is equals to minus of minus 2 into minus 2. Sorry, minus 2 into 2 that is minus 4. Again minus 3 into 3 minus 9 minus of minus plus 9. Again minus 4 plus 9 5. So 5 into minus that is minus 5 minus 5. Next cofactor of next element is a2 2 is equals to 2 plus 2 4. 4 is an odd an even number, right? Plus Determinant of cofactor of element and leaving this column and row. We have 3, 3, 4, 2. So that is 3, 3, 4, 2. Okay. So cofactor of element leaving this column and row 3, 3, 4, 2. Again that is equal to plus half. We have 3 into 2, that is 6, minus 4 into 3, that is 12. So again plus 6 minus 12, minus 6, minus 6 into plus, it is minus 6, minus 6. Next one. Next we have cofactor of this element, that is a 2, 3 is equals to, so 2 plus 3, 5. 5 is an odd number, therefore I minus determinant of, so cofactor of element this element. Leaving this column and row, we have 3 minus 2, again 4 minus 3, minus 3. Again that is equals to 3 into, that is minus of 3 into minus 3, minus 9, minus 4 into minus 2, that is minus 8. So minus of minus plus 4 into minus 2, minus 8, minus into minus plus 8. Again that is equals to, so minus 9 plus 8 you will get minus 1, minus 1 into minus 1 plus 1. Again we have a cofactor of 4, that is a 3, 1 is equal to 3 plus 1, 4. 4 is an even number, right? Plus determinant of leaving this row and column. We have minus 2, 3, then 1 minus 1. Again, simplification, that is equals to plus half. We have minus 2 into minus 1. Minus into minus plus 2 into 1, that is 2. Minus 1 into 3, that is 3. Again, that is equals to 2 minus 3, minus 1. Minus 1 into plus minus 1. Again, this cofactor of a 3, 2 is equal to 3 plus 2, 5. 5 is a number, right? Minus. Okay, cofactor of 3. So leaving this column and row, we have 2, 3, 3, 2 minus 1. So 3, 3, 2 minus 1, 2 minus 1. Again, that is equals to minus half, minus half. 3 into minus 1, minus 3, minus 2 into 3, that is 6. Again, minus 3, minus 6, minus 9, minus or minus, plus 9. Again, next we have a 3, 3, a 3, 3, that is equals to 3 plus 3, 6, 6 is even number, right? Plus determinant of. So leaving this column and row, we have 3 minus 2, again 2, 1. Again that is equals to plus as it is. Again 3 into 1, 3. Minus 2 into minus 2, minus 4. Minus or minus plus. So again that is equals to, so 3 plus 4, 7. Okay. So right, so we got the cofactors. Now we have to write what? Adjoint matrix. Adjoint matrix. Therefore, what is adjoint matrix? That is adjoint A. Adjoint A is equals to, so that is minus, don't write in a row only, column only, that is minus 1, we have minus 8, minus 10, minus 10, again minus 5, again minus 6, we have 1, then minus 1, 9, 7. This is what the adjoint matrix. Adjoint matrix. Again, we need to find what? Determinant of A. Determinant of A. Again, so determinant of A. That is determinant of A is equals to, we have a formula. So that is A11, capital A11 into small a11. Similarly, we have small a12 is into capital A12 plus small a13 into capital A13. Capital A13. Now substitute the values. So A11 into A11. What is small a11? It is here. What is capital A1? It is here. That is 3, alright. So 3 into minus 1, minus 3. Okay, again plus small a11, that is minus 2 into capital A11, 1 2 small a12 into capital A12. What is small a12? We have here that is minus 2. What is capital A12? We have minus 8. So minus 8 into minus 2, that is plus 16. Plus 16 again. We have plus small a1 into capital A13. Small a13 into capital A13. What is small a13? That is 3. What is capital A13? That is we have minus 10. So 3 into minus 10, we have minus 30. So minus of plus what a minus 30. Minus 30. Okay. Again, so this equals to. So we have minus 3 minus 30 minus 33 minus 33 and plus 16. We have minus 17 minus 17. So we got the value of what? Determinant of A. So therefore now we have to find A inverse R X. Therefore there is X is equals to A inverse into B, right? We have formula that X is equal to A inverse into B. What is X? It is a matrix having elements, that is X, Y, Z, which we need to find. Again, that is equals to A inverse. You know what is A inverse? That is 1 divided by determinant of A into adjoint A into what? B. You can write directly also. Again, that is equals to 1 divided by what is determinant value? Here we have minus 17. Minus 17 into adjoint matrix. What is adjoint matrix? We have adjoint matrix here. That is minus 1, minus 5, again minus 1. Then we have minus 8, minus 6, 9. Again we have here that is minus 10, 1, then 7. Okay. Again, so that is into what? B matrix. What is B matrix? That is constant matrix. 8, 1, 4, right? So now product of this again that is equals to write the minus 1 divided by 17 as it is. Minus 1 divided by 17 into. So product of two matrices. Product of two matrices, that is minus 1 into 8. Minus 8. Again minus 5 into 1. Minus 5. Again minus 1 into 4. Minus 4. Minus 4. Again. So minus 8 into plus 8. That is minus 64. Minus 64. Minus 1 into 6. So that is minus 6. Again 9 into 4. That is plus 32. Next. So minus 10 into 8. That is minus 80. Minus 80. Again 1 into 1 plus 1. Again 7 into 4. That is 28. Okay. 28. Again simplification. That is again simplification. Minus 1 divided by 17 half. So we have minus 8 minus 5 minus 4. That is minus 17. Minus 17. See here minus 60 minus 64 minus 6 plus 32. So we have minus 34. 34. Again minus 80 plus 1 plus 28. 8, that is 29 minus 8. We have minus 51. Minus 51. Okay. So now multiply minus 1 by 2 to each element. That is equals to minus 1 by 17 into minus 17. That is minus 1 by 17 into minus 17. So minus minus plus 17 ones, 17 ones. That is 1. Again minus, that is minus 1 divided by 17 into minus 34. So 17 ones, 17 twos, minus minus plus. Again we have minus, that is minus 1 divided by 17 into 51. 51 minus 51. Again 17 ones, 17 threes, minus into minus plus, that is 3. So this is what x. Therefore, what is x value? That is x is a matrix having elements x, y, z. Therefore, then x is equal to 1, comma y is equals to 2, comma z is equals to 3. Z is equal to 3. These are the values of x, y, z. Remember? So first find what A inverse. We know in the previous class we learned how to find the A inverse. Just for the value of A inverse, multiply what? Constant matrix and go for simplification. You will get the values of x, y, z. Next, same. Solve the system of linear equations by matrix method. X minus y plus z is equal to 4. 2x plus y minus z is equals to 0. X plus y plus z is equal to 2. We have to solve by using the matrix method. Dear children, remember one thing. We will be having one 5-mark question compulsory from this concept only. Andre solve the simultaneous equation and the one question 5-mark question compulsory ಕೇಳುತ್ತೆ 5-mark question ಒಂದು 5-mark question ಇರುತ್ತೆ same but that is same question ಕೇಳುತ್ತೆ solve the system of linear equations x minus y plus z is equal to 4 2x plus y minus 3z is equal to 0 x plus y plus z is equal to by using the matrix method okay so remember that again. It is important for a 5-mark question. Definitely, we will have one 5-mark question by this method. Okay. So similarly, we write what coefficient matrix. So what is coefficient matrix? That is A is equal to write the coefficients of x, y, z. See here, the x, y, z are the order, and the constants are the RHS. Therefore, what is the coefficient of x? 1. What is the coefficient of y? Minus 1. What is the coefficient of z? 1. So therefore, that is 1 minus 1 minus 1 1. Next, here what is the coefficient of x? 2. What is the coefficient of y? Any under 1 ಅಂತ 1. What is the coefficient of z? Minus 3. That is 2 1 minus 3 2 1 minus 3. Again, coefficient of x 1, coefficient of y 1, coefficient of z also 1. Okay, so therefore this 1 1 1. Now write constant matrix, variable matrix. What is the variable matrix? That is x is equal to variables. Here what are variables? X, y, z are called variables. Therefore x, y, z. Write the constant matrix. What is constant matrix? That is constants which are in RHS 4 0 2. So that is 4 0 2. Okay. So now we need to find what that is x is equal to A inverse into B. A inverse into B. Now we need to find A inverse. We know how to find A inverse. Again, find the cofactors. So let's find the cofactors of this matrix. That is we have A1 1 is equals to, so 1 plus 1 2. 2 is a even number, right? Plus again, okay. So that is determinant of, we have leaving this row and column 1 minus 3 1 1. Again that is equals to plus of, so 1 into 1 1 minus 1 into minus 3 minus 3 minus of minus plus. Again that is equals to 1 plus 3 4 4 into plus is plus itself. Again, cofactor of next element A1 2 is equals to 1 plus 3. Sorry, 1 plus 2 3. So 3 is an odd number, right? Minus determinant of cofactor of this element. Leaving this column under row, we have 2 minus 3 1 1 2 minus 3 1 1. Again, that is equal to minus of 2 into 1 2 minus 1 into minus 3. That is minus 3 minus 3 minus of minus again plus again plus 3. That is equals to 2 plus 3 5 5 into minus 1. That is minus 5 minus 5. So cofactor of A1 to the A row na column with what are the elements we have 2 minus 3 1 1. Okay, next cofactor of next element A1 3. So that is equals to 1 plus 3 4. 4 is an odd even number, right? Plus determinant of So cofactor of 1 number, leaving this column under first row, we have 2, 1, 1, 1. That is equals to plus of 2 into 1, 2 minus 1 into 1. That is 2 minus 1, 1. 1 into plus, that is plus 1. Again, cofactor of next element, a to 1. So 2 plus 1, 3. 3 is an odd number, right? Minus. So again, so cofactor of this, leaving this column under row. First column and second row, what are the elements? Minus 1, 1. Again 1, 1. Right? Leaving this under this 1, minus 1, 1, 1, 1. So that is equal to minus of minus 1 into minus 1. That is minus 1 into 1. Minus 1. Minus 1 into 1. That is 1 itself. Okay. So again that is equals to minus 1 minus 1 minus 2 minus of minus plus 2. Again cofactor of a to 2, that is equals to 2 plus 2, 4. 4 is an even number, right? Plus determinant of. So cofactor of this element, leaving this column and row, we have 1, 1, 1, 1. So 1, 1, 1, 1. That is equals to plus of 1 into 1, 1, minus 1 into 1, 1, 1 minus 1, 0, that is 0 itself. This cofactor of next element, that is 3, that is a 2, 3, 2 plus 3, 5, 5 is our number, right? Minus determinant of. So cofactor, leaving this column under row, we have 1 minus 1, then 1, 1. Okay, again that is equals to, we have minus of 1 into 1, 1, minus 1 into minus 1, minus 1, minus of minus plus 1. Again that is equals to 2, 1 plus 1, 2, 2 into minus, that is minus 2, minus 2. This cofactor of this element, a 3, 1 is equal to 3 plus 1, 4. 4 is even number, right? Plus determinant of. Leaving this row under column, we have minus 1, 1, 1, minus 3, that is equals to plus of. ಈ ಪ್ಲಸ್ ಅನ್ನು ಬೇಕಾದ್ರೆ ಬರೀಬಹುದು, ಬೇಕಾದ್ರೆ ಬಿಡಬಹುದು, ನೀವು ಬರಲೇಬೇಕು ಅಂತ ಇಲ್ಲ. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ minus 1 into minus 3, that is minus plus, that is we have 3 minus 1 into 1 is 1, so 3 minus 1 is 2. This cofactor of this element a 3 2 is equal to 3 plus 2, 5. 5 is our number, right? Minus. So cofactor of this, leaving this column and row, we have 1 1 2 minus 3, 1 1 2 minus 3. Again that is equal to minus of 1 into minus 3, minus 3, minus 2 into 1 is 2. Again minus 3, minus 2, minus 5, minus of minus plus 5. This cofactor of this element is a 3 3, that is equals to plus determinant of. So cofactor of 1, leaving this column and row, we have 1 minus 1. 1 minus 1, then we have 2, 1, 2, 1, again that is equals to, so 1 into 1, 1, minus 2 into minus 1, minus 2, minus of minus plus 2, it is equals to 3. Now we got the cofactors. So now we need to find what the adjoint matrix. Therefore, that is a adjoint of A is equals to, so that is 4 elements, and don't replace the elements with its cofactors. That becomes what a cofactor matrix. Now we are writing that what a adjoint matrix. Therefore, write in the column. That is 4. We have minus 5. Then we have 1, 2, 0, minus 2. Again 2, 5. Then we have 3. So this is adjoint matrix. Before we are find a determinant of A is equals to, that is A11 capital A11 into small a11. Again plus small a12 into capital A12 plus small a13 into capital A13. Again that is equal to, so what is small a11? We have here, that is 1. Capital A11 we have 4. Okay, again plus. So small a1 we have minus 1. What is capital A12? We have minus 5. minus 5 plus what is small a on 3 we have 1. What is capital A on 3 we have 1. Again that is equals to 1 into 4 4. So minus 1 into minus 5 that is minus and plus 1 into 5 that is plus 5. Again plus 1 into 1 that is 1 that is equals to 4 plus 1 5 4 plus 1 5 5 plus 5 that is 10. So this is determinant of it. So now we have to find that is x is equal to A inverse. We have x is equals to A inverse into B. X is equal to A inverse into B. Again that is equals to what is A inverse? 1 divided by determinant of A. 1 divided, we know what is A inverse? A inverse is equals to 1 divided by determinant of A into adjoint A. I'm writing directly. So 1 divided by determinant of A. What is the determinant of A value? That is 10 into adjoint matrix. Into what? Adjoint matrix. That is what is the adjoint matrix here? We have 4, 2, 2, minus 5, 0, again 5, 1, minus 2, 3. Okay. Into B matrix. What is B matrix here? So that is a constant matrix. 4, 0. Then we have 2. Okay. Now product of two matrices. Product of two matrices again that is equal to write the 1 by 10 as it is 1 by 10 of product of two matrices. That is 4 into 4 16 plus 2 into 0 0 plus 2 into 2 4. Okay. First row with the first column, second row with the first column, third row with the first column. Minus 5 into 4, that is minus 20. Minus 20. Again 0 into 0 0. Again 5 into 10. That is 5 into 2 plus 10. Again so third row with the first column 4 into 2. 4 into 1, 4. Again, minus 2 into 0, that is 0. Again, 3 into 2, that is plus 6. Okay. Now simplification. Again, that is equals to 1 by 10 into determinant matrix 16 plus 0 plus 4. We have 20. Again, minus 20 plus 10. We have 10 again. So 4 plus 6 we have 10. Okay. Now simplification that is equals to multiply 1 by 10 to each element. 1 by 10 to each element. To get 1 by 10 into 20. 10 ones are 10 twos are that is 2. Again so 10 by 1 by 10 into 10. We have 10 ones are 10 ones are that is 1. Again we have here that is 1. Okay. So this is x. Therefore, x is equals to 2, y is equals to 1. Sorry, here we have minus 10. Sorry, we have a minus 10. Minus 20 plus 10, we have minus 10. Okay, minus 1. So x is equal to 2, y is equal to minus 1, z is equals to 1. Matrix method. We have 2x plus 3y plus 3z is equal to 5. X minus 2y plus z is equal to minus 4. 2x minus y minus 2z is equal to 3. So write the coefficient matrix. So that is we have A is equal to coefficient matrix. Coefficient of x 2, coefficient of y 3, coefficient of z 3. That is 2, 3, 3. Here, coefficient of x1, coefficient of y minus 2, coefficient of z 1, 1 minus 2, 1. Again, coefficient of here, coefficient of x 3 minus 1 minus 2. That is 3 minus 1 minus 2. Variable matrix x is equals to variable matrix that is x, y, z. Then constant matrix B is equals to constant matrix that is 5 minus 4, 3. Okay. So now we need to find so we have formula that is x is equals to a inverse into b. We have to find a inverse. What is a inverse? So the a inverse is equals to 1 divided by determinant of a into adjoint a. And then we will find the adjoint of a as well as determinant of a. First we will find adjoint of a. So that is we have cofactors a11 is equals to plus. So you can multiply directly also. So that is one bracket leaving this and this minus 2 into minus 2, that is plus minus minus plus, that is 2 into 4 again minus. So minus 1 into 1 minus 1 minus or minus plus 1 again, that is equals to 5 again. So cofactor of this element a12 and the cofactor of the element and ಈ ಕಾಲಂನ ರೋ ನ ಬಿಟ್ರೆ what are the main elements? 1 1 3 minus 2. 1 into minus 2 is here we have minus half. 1 into minus 2, that is minus 2 again minus 3 into 1, that is 3 again, that is equals to minus 2 minus 3 minus 5 minus of minus plus, that is again plus 5 plus 5. This cofactor of this element a13 that is equals to plus half cofactor of 3 and we are leaving this on this row. So we have 1 minus 2 3 minus 1, therefore 1 into minus 1 minus 1 minus 3 into minus 2, that is minus 6 minus of minus plus 6 again, that is equals to minus 1 plus 6 5 into plus, that is 5 itself. Okay, again, so we have cofactor of this element that is a21 that is equals to we have right minus half. So cofactor of this element is leaving this and this we have 3 3 minus 1 minus 2, that is again 3 into minus 2 we have minus 6 again minus minus 1 into minus 3, that is minus 3 minus of minus plus 3 again, that is equals to minus 3 plus minus 6 plus 3 we have minus 3 minus of minus plus again the cofactor of this element a22 is equals to plus half cofactor of 200 leaving this and this we have 2 3 3 minus 2 again cofactor of element ಈ ಕಾಲಂ ಬಿಡಬೇಕು ರೋ ಬಿಟ್ರೆ 2 3 3 minus 2, therefore that is 2 into minus 2 we have minus 4 again minus 3 into 3 we have 9 again. So minus 4 minus 9 we have minus, that is equals to minus 13 minus 13 again is cofactor of element of this. Okay, this element that is a23 is equals to we have minus half. So leaving this column and row we have 2 3 3 minus 1, so that is 2 into minus 1 minus 2 minus 3 into 3, that is 9 again. So minus 2 minus 9 minus 11 into minus, that is equals to plus 11. Okay, next cofactor of element that is a31 that is equals to plus half. So leaving this row and column we have 3 3 minus 2 1 3 into 1 3 again minus minus 2 into 3 minus 6 minus of minus plus again, that is equals to 9. Next cofactor of a32 is equals to minus half. Leaving this column and row we have 2 3 1 1 2 3 1 1 2 into 1 2 minus 3 into 1, that is 3 again, that is equals to 1 minus 2 minus 3 we have minus 1 minus of minus plus 1. This cofactor of this element is a33 is equals to plus of cofactor of this we have leaving this column and row 2 3 1 minus 2 2 into minus 2 minus 4 minus 1 into 3, that is 3 again, that is equals to minus 4 minus 3 we have minus 7 minus 7. Okay, so now we got to find what determinant of A, that is equals to A11 into capital A11, that is 2, 2 into 5, 2 into 5, again plus we have so 3 into 5, 3 into 5, again 3 plus 3 into we have again 5. Okay, that is equals to 2 into 5, 10 plus 3 into 5, 15 plus 3 into 5, that is again 15. That is equals to 30 plus 10, 40. So we need to find the adjoint matrix before adjoint of A is equal to matrix, that is 5, 5, 5. Again, we have 3 minus 13, minus 13, 11. This we have 9, 1 minus 7, minus 7. Okay. So we have the value of x. So the x is equals to A inverse into B. So x is equal to A inverse into B. Again, that is equals to, what is A inverse? We have formula 1 divided by determinant of A into adjoint A. The value maatrane 1 divided by determinant of A. What is determinant of A value? That is 40 into adjoint matrix. What is the adjoint matrix? That is 5, 5, 5. Again 3 minus 13, 11, 9, 1 minus 7, minus 7. Okay. Into is to value no by A inverse there. Now into B matrix. What is B matrix? That is constant matrix. We have 5 minus 4, 3. Okay. Now simplification of this, that is equals to, again write 1 by 40 as it is. Okay. Next, that is 5 into 5, 25. Again 3 into minus 4, minus 12. Again we have 9 into 3 plus 27, plus 27. Again we have 5 into 5, 25, minus 13, minus to minus becomes plus minus 13, 13 into 4, it is 52, 50 plus 52. Again 1 into 3 plus 3, plus 3. Again we have 5 into 5, 25. Again 11 into minus 4, that is minus 44, minus 44. Again, so we have 7 into 3, that is minus 7 into 3, minus 21, minus 21. Again, we have that is 1 divided by 40 into matrix. So here, so 25 minus 12. So 25 plus 25, we have minus 12, we have that is plus 40, plus 40. Again 25 plus 52 plus 3, we have 80. 80. Again, so 25 minus 44 minus 20, that is minus 244 minus 21 plus 25. We have again minus 40, minus 40. Again, that is equals to multiply 1 by 40 to each. You will get that is 40 by 40, 1, 40, 80 by 40. We have 2. Again, minus 40 by 40, we have minus 1. Okay. So this is value of x. So therefore, x is small x is equals to 1 comma y is equals to 2 comma z is equals to minus 1, minus 1. So these are the values of x, y, z, x, y, z. Okay.